Trig. We are going to jump right into lesson 16, starting with 16.a. Now, please know lesson 16 is a review from Algebra 2, but still it goes over some difficult topics. So the first is complex fractions. Okay, so a complex fraction is when you have multiple fractions within each other. And to solve them, we're going to multiply everything by the least common denominator. Now, we do the same thing here when we're solving rationals, when we're adding and subtracting. So it's very common to what we've done before. So we're going to jump right in. I'm going to give you a complex fraction, a plus bx over x squared divided by mc plus kx over x squared c. So the first thing I need to do is figure out, I'm looking at my denominators, and I'm determining what the least common denominator is. I notice both of them have x squared, but only this one has c, so I'm going to have to use c. So you bring what they have in common and what they don't have in common. And I'm then going to multiply the top and bottom by my LCD of x squared c. Now, if it helps to visualize this, you have an invisible 1 underneath, and then I'm going to multiply. So if I multiply it by this first fraction, I know that the x squareds cancel when I multiply, and I'm left with c times a plus bx. And you can distribute now or later, but I just want you to see what we'd be multiplying. On the bottom, when I multiply these, the entire thing cancels because I have a c involved. You have that you're multiplying by the denominator, so I'm left with mc over kx. You can leave it that way, or you can distribute the top, ac plus bcx. I'm just putting my terms in alphabetical order. I like to keep my letters in alphabetical order, but either answer would be fine. Okay. Now I'm going to do a couple of these. You can pause the video any time and try one and then see if you get the same answer as me. So this next one, x divided by 4 plus x over 1 plus 1 over x. Okay, now this problem is way more difficult than the first, and here's why. You have two complex fractions here. You have, if I cover this up, this is a complex fraction, and so is this. So you have a complex fraction within a complex fraction, making this a lot more difficult. So we have to actually do a couple steps here. So the first thing I'm going to do is I'm going to rewrite that bottom complex fraction. So I have x over 1 plus 1 over x. Okay? So I'm just simplifying this part here. Okay, I have to do this first. Okay? Now the LCD here is just x. In fact, x is the only denominator. So I'm going to multiply everything by x, and that will give me x squared over 1x plus 1, because when I multiply these two pieces, the x's will cancel. So x times 1, right, I have to distribute, and x times 1 over x gives me 1. So this is what I'm left with. So now I'm going to rewrite the problem. So I have x divided by 4 plus x squared over x plus 1. Now both of these have an invisible denominator of 1. So if I look at these three denominators, I know that my LCD is x plus 1. And so that is what I'm going to multiply. Top and bottom. Doesn't matter whether you write it on the left or the right, as long as you know we're going to be distributing. So on the top, I'm going to be distributing x times x plus 1 because nothing is going to cancel. And on the bottom, I have 4 times x plus 1 plus x squared. The only place it cancels is here, right? Because the top and the bottom are going to cancel. It doesn't cancel here because this is over 1, so nothing cancels. You can't cross out the plus 1, okay? X plus 1 is very different than dividing by 1, so nothing cancels here. Nothing cancels here. X plus 1 over 1, they have to be identical to cancel. So then I'm going to simplify this. I have x squared plus x over x squared plus 4x plus 4. And you can factor this if you want. It's not really going to make much of a difference, so this can be your answer. Or if you like to factor out common, this is x plus 2 times x plus 2. But as you can see, nothing cancels. You could also write x plus 2 squared. I would just leave it like this. So this is your answer. So that is not review from Algebra 2. Next one. D divided by A plus MD divided by BD plus C. Now, this one is not a complex within a complex. It's just the fraction, okay? So I'm going to look at my other denominators. I just have a 1 and that has a 1. So my LCD is BD plus C. And I'm going to multiply everything by that little denominator right there. I'm going to highlight where I wrote LCD. So I'm going to multiply the whole thing by that denominator. So I have to multiply the top and bottom by BD plus C. And so that gives me D times BD plus C over A times BD plus C plus MD. Because this right here is the only place they cancel, right? Everywhere else you had to distribute, which gives me BD squared plus CD all over ABD plus AC plus MD. Nothing cancels, nothing can be simplified. You're just multiplying. Okay. Next one, or the next part of 16. 16.B covers abstract fractions. And we're going to skip that part. We don't cover it in Trig. Okay, sorry. The way I wrote skip doesn't even look like the word skip. So we're going to move on to 16.C, which is also review, and it's long division of polynomials. So I'm going to do 2 problems with you. Again, you can pause it, try it on your own, and then check with my answer. So the first, I'm going to go over this process. Remember, it is review. Divide x cubed plus 2x squared minus 2 by x minus 1. So I have 2 polynomials here. The first one is going to be written inside that box, long division box, and I have to put terms in order, and I have to add a 0 for any missing term. Okay? Sorry, I'm zoomed in so you can't see that, but I did write it on the side. Add 0 for any missing term. So when I write this on the inside, I have x cubed plus 2x squared. In between x squared and negative 2, I should have a 0x. I'm missing x with a degree of 1. And then I don't need all of this space. X minus 1 goes on the outside. So here we go. All we care about is the first term on the outside and the first term on the inside. X times what would give me x cubed? And in this case, it would be x squared. So that is the first term that's going to go up here. And you line it up above its like term. So once you find what this is, it goes up here. Okay? Now, maybe you're hopefully starting to remember this process. Now I have to distribute x squared times both terms on the outside. So x squared times x is x cubed. X squared times negative 1 is negative x squared. Now, I am going to subtract these, which makes this one negative and this one positive. Right? I'm subtracting both terms, and that's what is going to make this term cancel. This is gone. 2x squared plus 1x squared is 3x squared. And then I'm going to bring down the next term of 0x. Now we're going to repeat. All we care about is the outside x times what would produce 3x squared. So all I care about are these first two terms. X times 3x would give me the next term, and I'm going to simply write that above here, above its like term. I need to fill in something here. In this case, notice these are all positive, so this would be less 3x. Now I'm going to redistribute those. 3x times x is 3x squared. 3x times a negative 1 is negative 3x. Now remember, I'm subtracting these, so this makes this one negative and this one positive. These cancel. I have 3x. I bring down the last term of minus 2. So last time, x times what would give me 3x? That would give me my last term, x times 3. So 3 goes on top. These are all positive, so this is a positive 3. So this is the last term that goes up here. Hope you can see all those pencils. And then I redistribute it for a last time. 3 times x, 3x. 3 times negative 1 is negative 3. I'm subtracting these, so this makes this positive 3x a negative and a negative 3 positive. My remainder is 1. So this is how we write our answer. It's what was on top, x squared plus 3x plus 3, your remainder over what you divided it by. Let me zoom out so you can see that. So my answer is what is on top, my remainder over what I divided it by. And that is our answer. I'm going to do one more. Again, I'm going to write it. You can pause and try to work it out yourself. So this time I'm going to leave out the words. I have x cubed plus 2x minus 1 divided by x plus 3. So go ahead and try to set it up on your paper. You have x plus 3 out here. Make sure you fill this in, including any missing terms. I'm missing 0x squared plus 2x minus 1. Okay. And we're going to repeat that whole process over again. So I like to show what I'm thinking on the left. X times what gives me x cubed? Well, that would be x squared. Remember, all I care about is this first guy and this first guy. So this is x squared. So that's what I'm using up here. Distribute x squared times x is x cubed. X squared times 3 is 3x squared. So hopefully you notice that is why I need this 0x squared, otherwise I would have nowhere to put him. Okay, so always make sure you include a missing term. Notice when I subtracted both of these, change signs. So when you subtract, change the sign. Okay, so this is gone. This becomes negative 3x squared. Bring down the next term. 2x. Okay, all we care about are these first two terms. So x times what gives me negative 3x squared? Well, that would be negative 3x. So a negative 3x. Negative 3x times x is negative 3x squared. Negative 3 times 3 is negative 9x. I'm subtracting these, meaning I'm making them both positive. This cancels. 11x. Bring down the last term of minus 1. So last x times what equals 11x? Well, that would be 11. That's a positive 11. So 11 times x, 11 times 3. I'm subtracting, changing both their signs, and I get a remainder of negative 34. So my answer is what is on top? X squared minus 3x plus 11. My remainder, minus 34, divided by just the remainder is divided by the x plus 3, which is what you were dividing your polynomial by. So this is my answer. That concludes this lesson for homework. You're going to skip numbers 8, 9, 11, 12. Sorry, I should have fit in there. I like to put it in order. You should be skipping number 2. 8, 9, 11, 12, 27, and the last two, 29 and 30. You're welcome. That's a lot of problems.